Hi, I'm Josh Anderson, Director of Assistive Technology and the Data Project at Easter Seals Crossroads. And we're here at the ATIA Convention. Please enjoy this tech tip from the vendor hall.
Okay, my name is Klaus-Peter Hars from the German company Inventivio. And what we're doing is we have created an assistive learning technology that enables blind and visually impaired people to independently access, understand, learn, and rehearse with tactile learning information. So what we have here is the Tactonom Reader Flex. That is a foldable system. I can upfold it here. There's a camera integrated in the camera arm, and I can make it bigger so I can fix large tactile graphics onto it. I'm taking the map of the United States of America, and if you look at it, you can see a QR code on the top right corner of it. And the camera will scan the QR code and automatically upload information, embedded information, so that it becomes easier to understand. So now the camera scans the code and tells me what is on the graphic.
The individual states are separated by lines.
And this information is important for a blind person, because if you move over this graphic with your 10 fingers, it could be absolutely anything. So the system always tells me what to expect. And now I'm going to explore with my 10 fingers, and I'd like to know what this state is. So I'm going to put my finger onto it and press enter.
Missouri.
And it tells me what the state is, and also gives me details. If I don't always want to hear this information, I can reduce the amount of information. And now it'll just tell me the name of the state,
Colorado, Illinois, Michigan, North
in that
Dakota.
It is very precise and very fast. Now, if I wanted to know where, let's say, Arizona is, today someone would grab my wrist and dump me there. But as a blind person, that doesn't help me. This system knows where my fingers are, and it knows where Arizona is. So I just have to guide you there. Let me show you.
Explore, navigate to.
I have the function navigate to, and I'm going to choose Arizona. Press enter, enter, and now I can put my finger anywhere. It tells me to move my finger in the direction of 9 o'clock. And as I approach, the clicking sound becomes faster and faster and faster. That's why I know I'm always there. Now it tells me to go to 6 o'clock, it's the same thing. The clicking sound gets faster as I approach. This is Arizona.
Arizona.
This works in any graphic that we do, and that helps blind people to work independently. That is why this is called Tactonom Reader, and Tactonom comes from tactile and autonomy. This is what we want to do, to enable blind people to learn autonomously. But we cannot only work with 2D graphics, we can also work with 3D graphics. I have here a 3D model
Position the model
of a cathedral from Paris in my hands, which I'm placing onto the graphics, and I can now put my finger on any on the 3D model itself, and it'll tell me what it is. And
rooftop of the central
now I'm placing my finger on it on a small tower, and here's the bell tower, where you can even hear the bells of the actual bells of the cathedral. We are working with a non-profit organization called ProBlind, and this organization has in their database today 2,200 graphics. You can download all of them for free, upload your own graphics, change existing graphics, and automatically translate all of them into 25 languages. We are working, funded by the European Union, currently on 1,250 math graphics. This is one of them. That will be published in the database until the end of this summer, and then anyone can download these graphics. That means there will be about 100 graphics per grade in the database. And what I want to show you with this graphic is how we support blind people to work with graphs. So for the eye, it is very easy to follow these lines, but for the finger it is not. You very easily follow the wrong line. Therefore, we have the opportunity to explore lines with this system.
Explore object, explore lines.
So what now happens is the system automatically associates a sound with each of the two lines. I'm going to put my finger on the first one and follow the line, and here I have the juncture of two and you hear that the sound has become different, that means I've chosen the wrong turn. I'm finding back the initial line that I wanted to find, and here, up, wrong again, I'm tracing back and can continue on the line that I'm interested in. I can do the same for the other line.
Graph of the normal parabola y equals x squared.
And what you can hear now is I can even get the acoustic image of the graph, because I'm moving down the graph until the very end and get an idea of the graph in that way.
That's your tech tip for today. I want to say thank you to the Indiana Telephone Relay Access Corporation for sponsoring our captions today. My name is Brian Norton with the InData Project at Easter Seals Crossroads in Indiana.